All right, guys, well, I'm here today to teach you about some more physics ideas. So the first concept that we're going to be discussing today is something called speed. And when you think about speed, speed is something that is always going to be positive, or maybe zero. You never say, for example, that you were going negative 35 miles per hour. It doesn't really have a direction. You just say, I'm driving 70 miles an hour. It's just a number, right? It's always positive. It's always good, just a number without really a direction. And the way we find speed is you just take the absolute value of your velocity. Okay, and what that means, of course, is that it's just going to have the same units as a velocity in terms of like meters per second or miles per hour, inches per year, whatever that ends up being for the problem. Okay, now just for a very basic example, if you have a velocity which is 4 cosine of t minus 2, and you want to find the speed. I don't know why I wrote if twice, it should be an example. If we look at t equals 0, my velocity, I also meant to just do 4 cosine of t in parentheses and then minus 2. If you look at t equals 0, your velocity is equal to 4 cosine of 0 minus 2. That's equal to 4 minus 2, which is 2. So what that means is that your speed is equal to the absolute value of that velocity, which is just 2. If we look, for example, at t equals pi over 2, your velocity there would be 4 times cosine of pi over 2, which is 0, minus 2, which turns out to be negative 2. So your speed is still just the absolute value negative 2, which is just 2. Okay, cool. So that's just what speed is. So one of the questions that they love to ask on the AP test, and that you'll certainly see, is an object slowing down or speeding up? Is an object slowing down or speeding up? Okay, and when they ask these questions, if something is slowing down, what that means, of course, is the speed is decreasing. And if something is speeding up, what that means is the speed is increasing. Now, we want to be careful because like the velocity can be positive and negative. So the way that we want to approach these problems is we're going to find the velocity and the acceleration at that point. And then once you found those at that point, the question you're going to ask yourself is, are they the same sign? So if V and A have the same sign, what that means is that the speed is increasing. If V and A have opposite signs, what that means is the speed is decreasing. So logically, the reason this happens is like, okay, say your velocity is positive and your acceleration is positive. It means you're moving forward, and your velocity is going more positive. If you have a negative velocity and a negative acceleration, it means you're moving backwards, and the acceleration is causing you to become more negative. If they have opposite signs, like if you have, a positive velocity, so say your velocity is, like 8, but then your acceleration is like negative 2, then your velocity would actually be decreasing and would actually be going towards 0. So the way you want to think about this is really just like, do they have the same sign or do they have opposite signs? Basically, are the velocity and acceleration working together, or are they working against each other? Because if you have that situation, if your velocity is positive and your acceleration is negative, what that means is your velocity is positive, but it's decreasing, which is that case I just drew, that it goes 8, then 6, then 4, then 2. So, for example, if I give you this problem, like let's say I tell you we have a position, and I tell you that the position x of t is equal to 2t cubed minus 8t minus 7, and I ask, is it speeding up or is it slowing down at t equals 1? Okay, and again, the way that you want to go ahead and find the answers to these problems is you just want to find the velocity at time 1 and you want to find the acceleration at time 1, and then just check the signs and see, are they the same signs or are they opposite signs? And that's what they're going to be looking for on the AP test. So my velocity would just be x prime, so that would be 6t squared minus 8. So my velocity at time 1 would be 6 minus 8, which is negative 2. Your acceleration would be the derivative of velocity, so that would just be 12t. So my acceleration at time 1 would equal 12 times 1, which is 12. Okay, so to help us answer this question, what we'll do is we'll just say, like, okay, at t equals 1, my velocity is less than 0, and my acceleration is greater than 0, so they have opposite signs. And if they have opposite signs, what that means is that my speed is decreasing. Sometimes these questions will use the phrase speeding up and slowing down. Sometimes they'll ask us speed increasing or speed decreasing, but they mean the same thing. Okay, so that's what you do. Another example is if you have, for example, a velocity graph. So I give you a graph of the velocity over time, and we'll certainly see a fair amount of these problems, where it looks like this, 1, 2, 3, 4, 5, 6. Okay, and the graph looks like that, and then it does a little shoot whoop like that. And I might ask, like, okay, at t equals 3, is the speed increasing or decreasing? Okay, so again, you want to approach this problem in the same way. You're going to find the sine of the velocity and the acceleration. Now, with a graph like this, you can't find the exact value, but we can see, okay, at this point in time, so here's the dot where we are. Oops. So we're at this point right here. So we would say, like, okay, at t equals 3, my velocity is positive. And that happens because this is like a graph of v. We're above the axis. Also at t equals 3, but at t equals 3, my acceleration is the slope of velocity. It's the derivative of velocity. And my v has a negative slope. My v has a negative slope at t equals 3. So that means that my acceleration is negative. Okay, so again, we say at t equals 3, my velocity is positive, but my acceleration is negative. So that means that my speed would actually, be decreasing. If we looked at some other sides, so for example, if we looked at, I don't know, like what's happening at 4.5, well, at that point my velocity is negative and I have a negative slope. So velocity and acceleration are both negative. My speed would actually be increasing, kind of going away from that at the x-axis. If I looked at 1, I'd see the same thing. My velocity is positive because I'm above the graph. So my velocity is positive. I have positive slopes, so acceleration is positive. So the speed would be increasing there as well. But at t equals 3, again, they have opposite signs, so speed is decreasing. Okay, so that's speed and how to tell if it's increasing or decreasing. The next thing I want to talk about was this phrase total distance traveled. And when you see this phrase total distance traveled, that should bring to mind one thing. And I'll give you that equation in just a minute. But let's think about this. Suppose you go for your house, or you go out of your house for a run, and you go around your house, I don't know, you run, and you end up running 3 miles. Your displacement, meaning your change in position, will be 0. So displacement just ends up being a change in position. But that doesn't mean that you didn't run at all, right? You could have run 3 miles. It's just your final and your initial position are the same, so you had no displacement. But you want to find out, like, okay, how much did I travel? And the way you do that, so you want to account for like movement in a forward direction and a backward direction, is you want to say your total distance traveled, and the total distance that you traveled ends up just being the integral of speed. And of course, using the equation we just used, it is the integral of the absolute value of velocity, going from whatever time to whatever other time. So if a problem ever asks for total distance traveled, that's what you need to do. And in terms of an area, you're basically like counting all of it as positive. Whether it's moving forward or moving backwards, the absolute value will count it all as positive. So for example, let's say I tell you like an electron moves on the axis, chemistry, an electron moves on the x-axis with velocity v of t equals 2t times the sine of 3t plus 1. Okay, and then I ask you to find the distance it travels from t equals 0 to t equals 4. So 0 and 4, of course, are going to be our bounds. All right, so when you're doing a problem like this and you see the phrase like distance that it travels, you should immediately just be jumping to this equation. Okay, distance traveled, I'm just integrating an absolute value. Okay, so what this is going to do is this is going to be integral from 0 to 4 of the absolute value of 2t sine of 3t plus 1. Great, now we don't know how to integrate this, so what I'm going to tell you to do, just plug this in your calculator. Okay. So I'll give you a second, go ahead and pause the video, plug that in your calculator. And I did that, and I got 9.671. One thing you might have noticed, this took a little while. And for whatever reason, your calculator is just kind of slow when doing integrals to the absolute value. That's okay. It just might take 20 or 30 seconds for whatever reason. And if you're crunched for time in the AP test, just go on to the next problem and start that while you wait for it to calculate. But again, these are usually going to be calculator type problems. Let's do one more example here where I give you a graph. So here is a velocity versus time graph. And again, I'm going to actually give you some areas here. So we're going to have a similar shape, but I'm going to tell you, okay, so this area up here is 20, this area down here is 7, and let's say we go up to this point 10. Okay, and we start, of course, at the point 0. So I might ask you to find the displacement from 0 to 10. But I could also ask you another question to find the total distance traveled from 0 to 10. And the total distance traveled on the interval from 0 to 10. And these are actually two different problems. Now, the first one, A, that's something you guys could have done a while ago, well, maybe a couple days ago. So a displacement, remember, is just a change in position. And all we have to do there is just integrate the velocity from 0 to 10, and that'll tell me how much the position changed. So if I integrate the velocity, what I do is, okay, well, I have 20 above the graph, I have a negative 7 below the graph, so that's 13. But if I have to do the total distance traveled from 0 to 10, that's the integral 0 to 10 of absolute value of v of t. Okay, and the way we do this integral is we count all the area as positive. So even though it's under the axis, we're going to count that 7 as a positive. So the total distance traveled becomes 20 plus 7, which is 27. So this is saying, like, this person walked 27 miles, but the displacement is just the change in position. So this person's travel was only 13 miles from their beginning to their end position, even though they overall walked 27 miles. Okay, so that's the difference between the two, and that's distance traveled. Okay, bring me some questions to class, and thanks so much for watching. See you soon.